2.8, exercise 1 through 6. This section 2.8 has to do with solving polynomial inequalities in one variable. And we're going to determine the x values that cause this polynomial function to be 0, positive, and negative. So to find where this function is 0, we're going to set the function equal to 0. So we're going to say 0 equals quantity x plus 2 times quantity x plus 1 times quantity x minus 5. And solving each one of these factors for 0, we're going to have x plus 2 is equal to 0. So our 0 is going to be x equals negative 2. And then our next factor, x plus 1, we set equal to 0 as well. And solving for x, we have x equals negative 1. In this last factor, we have x minus 5 is equal to 0. So our last 0 is x equals 5. And each one of these zeros, since the zeros happen once, has a multiplicity of 1. Multiplicity of 1. Multiplicity of 1. And what really helps us to do is to look back at our understanding of parent functions of precalculus. And before I sketch that, if we multiply all these x values together, x times x times x, we're going to get x cubed. And then we're going to have a whole bunch of stuff, and then our final term is going to be 2 times 1 times negative 5, so we get negative 10. But really, the leading term is what we really care about. If you recall, the cubic parent function goes like this. Like it crosses the x-axis here at x equals 0 and resumes up like this. So that's going to be the function y equals x cubed. All right, so we're going to apply our understanding of multiplicities and the parent function. We see that the function starts low, so it's what we call odd positive. Starts low, ends high. So let's go ahead and mark our zeros on the x-axis. Here at x equals negative 2, that's 1, 0. X equals negative 1, that's another 0. And to the right here at x equals 5. And so odd positive is going to start low, and the multiplicity of 0 is 1, so we're going to start from down low, from negative infinity, go up and cross the x-axis, because multiplicity of 1, cross the x-axis, then come down here and cross the x-axis again at x equals negative 1, because we have multiplicity of 1. And finally, we're going to come down here a ways and cross finally the last time the x-axis at x equals 5. So in terms of answering our question here, a, b, and c, where is each function 0 that causes the polynomial 0? Well, that's going to be x equals negative 2, x equals negative 1, x equals 5. B, we're going to say where positive. So we're going to say f of x is greater than 0, which means positive, on the intervals, well, we're going to have between negative 2 and 1. The function goes above the x-axis between negative 2 and 1. So we'll say negative 2 to negative 1. And then the function value goes below the x-axis, negative, and at 5 resumes above the x-axis again. So greater than 5, less than infinity. And C, f of x is less than 0 on, well, what remains? We have greater than negative infinity, -2 and union -1 and 5. Greater than -1, less than 5. One thing that you can do on these things is make a sign chart. We're going to do this with other problems. If you just mark the zeros here at -2, -1, and 5, we just have to put the signs here. So we know we're going to be negative less than -2. So negative, multiplicity is 1 at -2, so we switch. And then at -1 is multiplicity of 1, so we're going to switch signs. And finally at 5, we have multiplicity of 1, so we switch signs. So that's what a sign chart looks like. And as far as graphing, graphical confirmation, if here I have the function enter, and we graph the function, we see the key values. I'm going to change the menu and go to window zoom and change the Y minimum to maybe -25. I think that'll work. We're pretty close anyway. Yeah, well, that's not quite, but we get the picture, right? Between -2 and -1, greater than 0, less than 0 between -1 and 5, and greater than 0 between 5, greater than 5, less than infinity. Okay, next odd number problem. Let's take a look at problem number 3. Here we have, we're going to set this equal to 0, so put 0 equals to point x plus 7, point x plus 4, and quantity x minus 6. So we're going to set each factor equal to 0. So to find our zeros, we put x plus 7 is equal to 0. So therefore x is equal to -7. That's one of our zeros. We set the next factor, x plus 4, equal to 0. And solving for x, we have x is equal to -4. And finally, the last zero we have, which is actually a double zero, x minus 6 is equal to 0. And solving for x, we have x is equal to 6. As far as multiplicities, we have the -7. We have multiplicity is equal to 1. X equals -4 is a multiplicity of 1. And x equals 6 is a multiplicity of 2, because there are 2 zeros. And that's going to have significance when we graph. Now, when we multiply all these x's together, we get x times x squared. We're going to get a leading term of x to the 4th power. And then our final term is going to be negative. This will be 36 times 4 times 7. So that'll be 36 times 28. Pretty big number. But that tells us that we're going to have an even positive. So just conceptually, what we're looking at is we're going to be starting high, starting from on high, and ending on high. So that's going to be the general thing that's happening here. So taking that into account, let's go ahead and mark the zeros on this graph. So we have -7, we have -4, and we have 6. Not quite to scale, but it'll be good enough for us. So we're coming from on high, and at this zero of -7, we have a multiplicity of 1. So we're going to come down, we're going to touch, we're going to cross the x-axis. Odd number of multiplicities will cross the x-axis. We'll come down, and then we're going to go up to -4. And what is the multiplicity of 0, -4? That's a multiplicity of 1. So we cross the x-axis. Then we're going to come up here quite a ways and go down to our last 0, which is 6. And we have a multiplicity of 2. So we're going to not cross the x-axis, but touch the x-axis at x equals 6, and then resume our upward flight. And so answer A, our zeros we have x equals -7, x equals -4, and x equals 6. And as far as b, we have f of x is greater than 0 on, meaning on the interval, well, greater than -infinity. See, that's above the x-axis, all the way to less than -7. And then -4 to 6, so union -4, 6. And then at 6, the value function is 0, but greater than 6, we're going to have greater than 6, less than infinity. So that's going to be our positive. And finally, answer C, f of x is less than 0 on, well, just everything that we have just between -7 and -4. And so this will be our answer. And I think I have this. Let's go look at this. I have this graph too. And if we graph the thing, calculator, Control I, add graph. Okay, that's it right there. And we see the key points here, -7, -4, and 6. And we can change our scale of this. Go to menu, zoom, settings. It's mainly changing the y value. So y minimum, I'm going to make -100. And y maximum, I'm going to make 500, something like that. I don't know if that's what it's going to be. Then we graph. Okay, we don't see the maximum. We're going to adjust one more time here. Menu, window zoom, window settings. Okay, we're going to go -500 for the minimum, and I'm going to go to 2,000 for the maximum. And okay, that's pretty clear. Okay, -7, -4, greater than 0 between -4 and 6. So that confirms quite well. Next on our problem, which is 5. And we're going to set in, let's say 0 equals quantity 2x squared plus 5 times quantity x minus 8 squared, and then it's quantity x plus 1. And that's going to be to the 3rd power. So our zeros we get by setting each one of these factors equal to 0. So we have 2x squared plus 5 is equal to 0. In solving, if we subtract 5, there's going to be no solution, because for this to be there be a solution, this x squared would have to be negative to offset this positive to make the thing equal 0. So there's going to be no real 0 here. No real 0 for that first factor. For the second one, we're going to have x minus 8 equals 0. And so the 0 would actually be, if we solve for x, x equals 8. And that's going to be a multiplicity of 2, because it's squared. And the last 0 we have is, we set x plus 1 equals 0. And solving for x, we have x equals -1. And for this one, we have a multiplicity of 3. And we're going to analyze our leading term here. If we go ahead and multiply everything out, we're going to have 2x squared times x squared. So that's going to be 2x to the 4th power times x cubed. So our leading coefficient is going to be, our leading term is going to be 2x to the 7th power. which is going to be odd, meaning that our function is going to start low and end high. So this thing's going to start low and end high. That's just a general shape. It's an odd positive. So let's mark our zeros. We don't have any zero represented by this first factor. And then we have a 0 at x equals 8. It's going to mark over here x equals 8. And we have a real 0 here at x equals -1. And then we have a odd positive. So, and let's see what our multiplicity is. So we're coming from low, and our multiplicity is 3. So we're going to go through the x-axis, but with a little jog right here. And then we're going to go up quite a ways, and then we're going to come back on down. And our multiplicity at 8 is what? 2. So at 2, we're going to touch the x-axis. At 8, we're going to touch the x-axis and resume upward flight. So conceptually, this is what our graph of our function is going to look like. And so we say we have our zeros. We have x equals -1, x equals 8. And then b, f of x is greater than 0 on the interval. Well, we have greater than -1 up to less than 8. And then we take a break at 8 itself, because that's when the function value is 0, and we go from greater than 8 to less than infinity. And then the last part, we have c, we have f of x is less than 0 on, well, we're just going to have this section here to the left, greater than -infinity, all the way up to less than -1. So that should be everything. Let's go ahead and confirm graphically if we can. Press Control I. Add graph. We'll get our function here. And if we graph, we see the 0 at -1. We don't see the 0 at 8. We're going to need to change the scale immensely. So to do that, go to Menu, Window Zoom, Window Settings, and we'll make this Y minimum, I think -20,000. And then our Y maximum, I'm going to make, I think 200,000. Okay, go down here, press Enter. Okay, we can see well enough. I'm going to move this function out of the way. So you see we cross the x-axis at x equals -1. And then we go up, get a maximum, relative maximum, and come down and touch the x-axis again at x equals 8, but not cross the x-axis. So, graphical confirmation. So we're going to box in our answers as correct. Anyway, good luck on your even number problems. It's a demonstration of your learning. And thank you for viewing.